Okay, so this morning I'm going to look at pulse width modulation, which sounds quite exciting, but basically it's all about this light here. So in the projects, if you look at this project here, you'll have seen in other versions or in the API, you've got something called an analogWrite, which is where you make this LED either brighter or dimmer. So it can, normally an LED is either off or on. So how does it work? How do you make an LED somewhere in between, somewhere sort of a little bit brighter and dimmer? And this is one of the key features of the Arduino. So if you look at this sketch here, it's really, really simple. We're taking pin 3 and we're saying output, and on pin 3 we're saying value 100. Now this can go between 0 and 255. If I put in 0 and then I do an upload, if you watch there, it's off. If I put in 255 and upload, it's on full. And these are the values that you'd expect. So this is how an LED works. And in the background, if you look here at the oscilloscope, this is the probe wire here. So this oscilloscope is currently running from, that's 0 volts. These are each 1 volt divisions. So if I put the probe against the 5 volt line, we can see that it jumps up 5 divisions. If I put it against the 3.3 volt line, we can see it jumps up about 3.5 divisions. There's ground. And this is the LED pin, which is currently running at 5 volts. So what happens if I put in a value in here, somewhere intermediate, something like 100, so that's about a third brightness, and I upload that sketch, we can see that this isn't quite as bright. If I put in a value like, it's perhaps not easy to tell on the video, if I put in a value like 10 here, you'll see that it's quite a bit dimmer, and you can see that in the video. Now the astute amongst you, if you look in the background here on the oscilloscope, we'll see what's actually going on. So what's happening is, this is 1 millisecond across there. The Arduino is turning the LED on and off. So if I spread that out, you can see the pulses here. It turns on for a little bit and then it turns off. And this is 10 divided by 255 of the time it's on, and then the rest of the time, 254 divided by 255, it's off. So if I put this in as something like 25, then we would expect this to be on about 10% of the time. And if we look at that, if I move this along here, let's open up the divisions a bit. We can see there's one pulse and there's the next pulse. And that's about 1, 2, 3, 4, 5, 6, 7, 8. And this is about 1/8 of a width of a pulse. You can't get it exactly right on there. And that is how pulse width modulation works and how you make an analog write.